All right, so let's do the last part of our question. Just as a refresher, I'll just show you the question and then we'll solve it. Don't worry, this is a short one. It's not as long as the last video. So we discussed the collinearity and coplanarity of the four vectors here. We found out which ones are collinear and which ones aren't, so which ones form the basis of 3D space. And now we're just doing this last part, right? The fourth vector, so the one that doesn't form the basis for 3D space, as a linear combination of the other three. So that's what we're going to do here, and then we will call it a day. So let vector w be equal to a times u plus b times w, or not w, v. Sorry, my brain is currently malfunctioning. It is far too late. So we have to do this, and same thing as before, only we've got three vectors, and we've also got three dimensions for each vector. So the idea is still the same. We're going to end up with systems of equations. They'll just be a little more annoying to solve. So let's plug in everything that we've got. We've got 1, 0, and -1 is equal to a times our vector u, which is just 1, 1, and 1, plus b times v, which is 1, 2, and 3, plus c times -1, -1, and 1. Okay, so take a minute, try it. Again, I've already kind of spoiled what you have to do. You'll end up with a system of three equations with three unknowns, but still, that's okay. And unpause the video when you're ready to see the solution. Okay, so let's finish it off here. I've got my three equations that I want to write over here. So I've got, what do I have here? 1 is equal to a, because I've just got one of them, then plus b minus c. Equation 2, 0 is going to be equal to a plus 2b minus c. And then last but not least, I'll have -1 is equal to a plus 3b. And then what do I have here? Plus c this time, not negative. Just want to make sure I don't flip any of my signs because that would be pretty catastrophic. So now I'm going to turn this system of three equations with three unknowns into two equations with two unknowns by combining two pairs of my equations. Of course, you know how to solve a system of three equations with three unknowns, but my first equation here, I'm just going to do equation number 1 plus equation number 3, and that's going to give me 2a plus 4b, and that'll be, what do I have here, equal to, sorry, 0. Like I said, my mental math is a little slow now, plus and minus 1. I'm just making sure I was looking at the right equations. And then this one's going to be equation number 2. Let's see, do I want to add or do I want to subtract? Sure, I'll just do 2 and 3. Yeah, I do want to add because then the c's will cancel out. So the c's will cancel out here. Then I'll be left with, what do I have here? 5b, 2a, and -1. Okay. So now that I've got these two equations, they line up really nice because I've got 2a and 2a here. So now I'm going to do, I could rename this equation number 4 and 5, but it's not, there's no point. So I'm going to subtract the top one from the bottom just so I end up with a positive b value. So these two cancel out. Then 5 minus 4 will give me 1b. And then -1 minus 0 will just still give me -1. So I've got my b value of negative 1. And now let's pick an equation to plug it into. I'm just going to pick this equation up here. So 2a minus 4 is equal to 0, 2a is equal to 4, and a is just equal to 2. And then last but not least, I'm just going to pick equation number 1 up here just because it has the lowest coefficients for each term. So 1 will be equal to my a value of 2 minus 1 because that's my b value minus c. And now 2 minus 1 will just be 1. And move the 1 over to the other side, and it just becomes 0 is equal to negative c. And obviously, if negative c is equal to 0, then c is also equal to 0. So now we have our three answers. Just don't forget your final statement. Therefore, vector w will be equal to my a value of 2u plus, oh, not plus, because my b value is negative. My apologies. So minus v. And then, well, 0x. So I guess I could write it there, but actually, it actually has to be written because that's what the question's asking us for. It has to be written as a linear combination of the other three, so we don't want to leave anything ambiguous. We want the reader to know that the value that goes in front of the x is 0. Okay, so thank you for bearing with me, especially with my mental math that was falling apart near the end there. But, ooh, let's not forget the homework from the Algebra and Geometry textbook. It'll be homework on page 153, and it's numbers 3 to 7. Okay, so I hope that made sense. If you have any questions, you're always free to come for extra help, email me, or just ask me in class. But yeah, have a great day, and I'll see you tomorrow.